Okay, some other review problems we had were dealing with confidence intervals. And we talked about this in our notes for confidence intervals. We're going to use a particular z-score. And we had that data in our notes. And it was over here. This is kind of what we had. And for 90% confidence interval, we use z-scores of 1.645. For 95%, we use z-score of 1.960. And for 99%, we use a z-score of 2.576. And we're going to use these in this formula that we had. And we have a nice formula for the error when we're determining our confidence intervals. I'm not going to go too much into theory because we talked about this in class, so this is just how to basically use this. So this is my error, and I know my confidence interval will be the sample mean plus or minus the error. So what we're trying to do is find confidence intervals. So we had some of these, and we've done 95, so let's do 99%, so we'll do number 9, but it just depends on what kind of confidence interval you're using for the value you use. So if we're going to do number 9, they want a 99% confidence interval. So since it's a 99% confidence interval, we're going to use z to be, right over here, 2.576. So right away we determine that, and I will give you that information. So for 99%, z will equal 2.576. And these problems are all done basically the same way. This is a 99% confidence interval. This is a 95% confidence interval, so we'd use z to be 1.96. And this is a 90%, and we'd use z to be 1.645. And otherwise, they're all done basically the same way. So let's take a look at number 9a. And A, we are given our data that our sample mean, we use a little x bar for that, is equal to 76. And my standard deviation, we use a little s in this case, was 8.1. And my sample number, n, was equal to 180. So if I want to find the confidence interval, I know the confidence interval equals the sample mean plus or minus the error. So I have to find the error first, and we have that formula given to us on our notes. So my error is going to be equal to z, and in this case, this is what I'm going to use for z. That depends on this, what you're going to use for z, times s over the square root of n. That's going to give me the error. So in this case, my error is going to be z, which is going to be, since it's a 99%, 2.576 times s, and s was 8.1, divided by the square root of n, so that's going to be the square root of 180. And we just put that on a calculator and figure out what our error is. Now remember, if it was a 95% confidence interval, everything would be the same except z would be 1.96. If it was a 90%, everything would be the same except z would be 1.645. That's all. Then you just put your data in, then you calculate it out. So the way I do this, I would take 8.1 and divide it by the square root of 180. So there's my little 99-cent calculator, or my $2 calculator, I should say. And let's say 8.1 divided by the square root, and I got a little square root function here, of 180. And I just press enter. And I get that 0.6037, something like that. So I can write it down like this just so you can see. 2.576 times, and this is going to be 0.6037 and some other numbers. And I've already got that on my calculator, so I'll just put times. So I just press times, and then my z value, which is 2.576. 2.576. And I press enter, And there's my error, 1.555, and we say round off to 2 places. So this is going to be approximately, so my error will be approximately 1.55, we round off to 56. So there's my error. Now my confidence interval is just my mean, so my confidence interval is just my sample mean plus or minus the error. So it's going to be equal to my sample mean, which was what? 76, plus or minus the error, which was 1.56. And that's going to be where I'm going to have a 99% confidence that my population mean will be in this interval. So I take 76 plus, so if I add this, 76 plus 1.56 and 76 minus 1.56. Well, if we add these, this is easy. This is just 77.56. And this is a little bit trickier, so I'll just take my calculator and I'll say 76 minus, oops, you can't see that, there we go. 76 minus 1.56, and I get 74.44. So this is the mean plus the error, the mean minus the error, and my population mean will be in between there, so it's going to be greater than or equal to this and less than or equal to that. And that's my confidence interval. And that's all you got to do. So now I can say with 99% confidence that my population mean will be in between 74.44 and 77.56. Okay, that's all there is. So hopefully that makes sense.